Okay, let's quickly run through U substitution. Very, very simple concept. Let's say, okay, first thing you need to know is you need to know differentials for U substitution. Okay, that's the most important part. So look at this. You're given an integral, let's say x3, and in the parentheses we have x to the 4 plus 2 dx. The goal of U substitution essentially is to cancel out one of these terms. So either you're going to cancel out this one or this one. Now, my advice to students is always find a parent and a child function. So what's the relationship? The parent is the main function and the child is the differential of the parent. So dy over dx. So look at this. If we differentiate this function inside the parentheses, we can then get 12x raised to the 3. So essentially, this 3 will cancel out that x to the 3. So after you identify your parent, just look for the parent. Don't use the differential, use the parent. Okay? And then you set the parent equal to u, whatever the parent is. And then you solve du is equal to 12x cubed plus or times dx. And then you divide both sides by 12x because you're trying to solve for dx, my apologies. That's your goal. Your goal is always to solve for dx with U substitution. Okay, I'll make this clear in 1 second. That's like an overall idea of what you're trying to achieve. So you're trying to look at the differential or the integral, and then you want to be able to identify the parent and the child. Again, the parent, the relationship of the child to the parent is that the child is the differential of the parent. Okay, so let's look at this one. So in this case, we can clearly see that if I differentiate 1 plus x squared, that is, I'm left with 2x. Okay, so first things first, we can identify for u. We identify u as 1 plus x squared. Then we solve du. That just means the differential for u. It's 1, the differential for u, the differential of 1 is 0, the differential of x squared is 2x times dx. Then we divide both sides by 2x. So then I'm left with du over 2x is equal to dx. Okay, so now we got dx. Now here's what you're going to do. You're going to write the integral. Okay, maybe let me just write the full one first. 1 plus x squared dx. Okay, now we're going to substitute what we know. Well, we know that we used the entire function, the inner function, as u. And then we can also substitute for dx. So dx was du over 2x. And look at that. Boom, boom. Now we're left with the integral of u du. So we can then integrate for u. So how do we integrate the square root? Very easy. We can first rewrite it in the exponential form times du. Then we can integrate it. Very, very easy. It's u 1 over 2 plus 1 over u, or 1/2 plus 1. So that gives me u 3 over 2 over 3 over 2. And then I can rewrite and I can just bring back what u was. So first, let's multiply with the reciprocal. So that cancels. So we're left with 2u. So 2. And then, look at this. We have 1 plus x squared. So just bring back whatever u was over, let's add the plus c there, over 3. And this was raised to the 2 over 3 plus c. Or you can rewrite this back in root form, however you want it. However, most teachers would accept this final answer. And that's how you do it. Very, very simple. Okay, I'm not going to say it's very simple. But yeah, that's pretty much how you solve U substitution. Okay, that's the first one. Okay, let's look at this next integral where we have the integral of sine x over square root x dx. Now, this one's a little bit tricky because you might get confused here. Well, if I use u as the square root of x, well, aren't they both going to be, for instance, sine u over u? Well, no, not necessarily, because this u can be considered as g of x, and we have f of x over here, right? So sine square root u is different than the square root of u as a function. That's just a little bit of theory. So in this particular case, I'm going to use the g of x, or the function inside sine, as the u. Okay, so what do we get? We get, I will say this one's a little bit challenging because this is a university integral, maybe high school. I haven't seen it though, but a little bit challenging. Anyway, I like to put a bit of challenging questions. Okay, so let's integrate for, or differentiate for x. So du over dx will simply be multiply forward 1 over 2, and then we minus 1, so that becomes negative half. So I can just write that as 1 over 2 square root x. This you should already know, that the differential of the square root of x is 1 over 2 square root x. If you still don't know that, maybe just something you could review. Anyway, so I'm going to cross multiply. So we have du times 2x, 2 root x, and this is equal to dx. Okay, now that we got our information, we can write this integral here at the bottom with u substitution. So I'm going to substitute the sine of u times, so we know it's 2 root x times du over root x. So I can now cancel out these 2 root x's, and then I can bring my integral, or my constant, forward. It just makes the integral a little bit easier. So that's the integral of sine u du. And we know that the integral of sine u is negative cosine u. So that's going to be multiply negative cosine u plus c. So I can just rearrange the negative and the 2, so we get negative cosine 2, and then bring back whatever u was. U was the square root of x plus c. And yeah, that's how we do the second one. Okay, so let's look at this next example. So this example was from an IB exam, 2025 predicted exam, at least. Let me just clarify. So look at this case now. Well, we got sine x and cosine x. Now I need to decide myself which one am I going to make u for this particular question. Well, let me give you a walkthrough quick. If you make sine u, you can cancel out the cosines effectively. If you make cosine equal to u, you will get that du is equal to negative sine x dx. You see, now you're working with a negative equation, which just gives you a higher percentage chance of making a mistake. So in this particular case, what I'm going to do is I'm going to set cosine, or sine, equal to u. Okay? Then we have du, which is cosine times dx. And then I can just divide both sides by cosine. That gives me dx. Okay. So let's plug back in what we got. We got pi over 2 is 0. 8 sine, but sine we just set equal to 0, or to u. So I'm going to say 8u times cosine x over times du, my apologies, and then we have cosine x at the bottom. And look at that, effectively cancel out. Now I'll just rearrange my integral to place the 8 outside. Makes it a little bit easier. And then we're left with a u du. I'm going to erase this. Okay, now we integrate for u. Very, very straightforward. U will just be u squared over 2. I guess I could have just left the 8 there. Actually, let me bring back this 8. We can actually do whatever we want, by the way. Actually, let me leave it on the outside, just to continue my explanation. Okay. And we want to evaluate this at pi over 2 and 0. So now I will bring back my sine. So this is going to be 8 times sine of the upper limit squared. Sorry, it's only the u that's squared, not the entire thing. Oof, that's really ugly. Minus the lower limit, which was sine of 0 squared over 2. And then, well, this is pretty straightforward. Sine 0 is 0, so that cancels out. Sine 90 can be found at this particular point. So we know that sine correlates to my y coordinate on my axis. So therefore, sine of 90 is 1. So this will be 1 squared over 2, which is just simply 1/2. And so my final answer will be 4 units squared. I've decided to add another 3 examples because I realized that this concept might be a little bit tricky for a lot of students to get, and how to identify when to use U substitution. So I thought it might be best if I just add more examples. Okay, so remember what I said earlier about adding or looking for the parent and its derivative. In this case, we can clearly see that this is the parent and there's the differential. Because if I said, let's say u is equal to x4 plus 2, and if I differentiate u, I get 4x3, and I can just swap these two positions around. So du is equal to 4x3 over x dx. Okay, so now we can see, well, 4x3 belongs to the family of x cubed, right? 4x cubed. It belongs to the same family tree. So if that's the case, well, then we can use U substitution, right? Because that's all essentially what we're looking for. So let's rewrite what we know. So 3x and then cosine u, since I set u equal to 4x cubed plus 2. And then we also substitute for whatever dx was. So dx was du over 4x3. Okay, you see, it will always cancel out. So I'll bring this 1 over 4 forward. 1 over 4 cosine u du. Let's integrate cosine. The integral of cosine is sine. So this is 1 over 4 times sine of u plus c, because we have an indefinite integral. And then I can just bring back whatever's missing. So whatever u was. So sine x4 plus 2. Ah! Why is it equal sign here? Oh, hell no. Which is 1 over 4 sine plus c. There we go. That's our final answer. For the next one's a little bit challenging. So we have ln and x. Well, it would be quite silly to, because the integral of ln is something like x minus ln x, x minus x ln x. So we don't want that. Let me show you what actually happens if you make this x below the line u. Let me show you, just so you can understand. So that means du over 1 is equal to dx, right? After solving. So if I then bring this into the integral, I'm left with this. ln x over u times du. You see, now we can't differentiate because we have no respect to x. So that does not work. Okay, it does not work. You'll quickly figure out, by the way, if you use U substitution, you'll figure out like, whoa, this actually does not work. Okay, so if that's the case, well, let's make u ln x. So therefore du is 1 over x. So I can then cross multiply to get rid of it. So it's going to be du times x is equal to dx. And look at that, just simply cancels out again. Okay, so we have the integral of ln, or I guess we can just say the integral of u over x, and then let's substitute dx. Dx was du times x, and we want to evaluate this at en1. Again, look, the x's cancel out. So let's solve this integral. So that's 2 and we want to evaluate this at the points 1 and 0. So let me just quickly bring back our ln. So our ln e, in this case we have ln x, and we want to raise this to the 2 over 2, and we want to evaluate this at e and 1. So let's write that out. So that's going to be ln e raised to the 2 over 2 minus ln 1 over 2 squared. Ln e, we know that ln has a base of e, so whenever you see a copy like this, the answer is always 1, so that's simply going to be 1 over 2. And then ln 1 is always 0. Why is that? Because ln 1 e equals 0. Why? Because e raised to the 0 is equal to 1. So there's your final answer. Units squared. 1 over 2. All right. Let's get to this one. Here's another tricky one. I mean, if you like really think about it, it's not that complicated. It's actually very straightforward. Because look at this integral, right? Think for yourself. Well, I have 3 cosines and I have 1 sine. So which one do I want to cancel? Which one would be easier to cancel? 3 cosines or 1 sine? Obviously the 1 sine, right? So in this case, we can set cosine theta equal to u. So the differential of cosine theta is negative sine theta times dx, and then change its positions. So we have, sorry, that's supposed to be d theta. That just means we're integrating respect to theta. So in this case, I can just swap them around, bring this one down because we always want to isolate dx. Okay, now bring back what we know. So that's going to be u3 times sine theta times du over negative sine theta. Those two cancel out. I'll bring the negative symbol, I'll bring it out here. We want to integrate u to the 3 by just simply using the power rule. So that's pretty much going to be u4 over 4 plus c, and then we can bring back whatever u was. So u was cosine theta. So this is going to be negative cosine raised to the 4 theta over 4 plus c. And there's your final answer. Okay, so that's how we do u substitution. I gave you some of the extreme examples. Hopefully this gives you an easier idea of how to do it. Yeah, in my particular video, I did examples that could be considered difficult. I mean, I would argue they're pretty easy. However, maybe my judgment is not that good, so it's okay. Let me just quickly rerun over what you need to know. You need to know how to differentiate between a parent and a child. However, only some teachers use this terminology, by the way, parent and a child. Some other teachers use some other language, but that's totally up to them. Depends on probably which uni they went to. So I think the easiest way is to look for the parent. The parent's the big function. The child is the differential of the parent. Set the parent equal to u, and then eliminate the child. Okay, sounded pretty bad, but I didn't mean it that way. Anyway, all right, everyone, have a fantastic evening. Goodbye. Best of luck with your exams, and remember, as always,